last session?
No, Ravi.
Okay. So So, last session we had finished at your rebasing, right? So, we looked at how you can merge your changes on the local machine as in your local repository as well as your central repository. That is where we had stopped in the last session. Now we'll continue from there. The next topic that we are going to look at is your stashing. Now, stashing is another area that we have in your local repository. So, like we have your working area, we have the staging area, we have the local repository, and then we also have your stashing area. Okay, stashed area as we call it. So, in total, essentially, in total, we have 4 areas. Okay, one moment. Okay, so we have this, right? So now we know that we have your 3 areas. We have the staging area, then we have so working area basically where we make the changes. Staging area, whenever we want to commit our changes, we move it to the staging area, and then we have the local repository, right? So whenever you want to commit your changes, we basically when once we commit it, it will be committed in the local repository. Now between them, we also have one more area which is your stash area. Okay. Now stashed area can be useful when whenever you have any incomplete changes. All right, the changes it's not yet complete, and you want to move to some other branch. You want to switch to some other branch. For example, let's say we'll go to this terraform.tf file, or let's create a new file. Let's call this as um, python.py, and let's say this is a test change, and this is not complete. Now if you see the data, you will see that it is there in my working area. And if you look at the branch, so right now I'm in the main branch. And let's at this point I want to switch to some other branch. So again, this is incomplete, but let's have got some critical issue that needs to be fixed. I cannot commit this because it is not yet complete. I don't want to save this because the changes, it's not yet complete. And at the same time, I want to move to some other branch. So let's say if I try doing this, okay, check out feature 001. Okay. Now, it is telling me it has switched to this branch, and you see the data, right? I've got this data also. So this change that I had done, it was there in my main branch. Now, when I did a checkout to another branch, this incomplete change also came to my feature branch, right? Now, this is not right? This should not be happening, right? So, whatever the incomplete changes I have, I want it to be in the main branch only. I don't want it to be, copied to the new branch or any other branch. So, only when I want it, once it is completed, I will go ahead and merge it. So now what do we do with this data? How do we avoid this? Now this is where we have your stashing. Okay, the concept of your stashing comes in. So let's say you have this feature 001 branch in the working area, you have some incomplete changes. Now you want to maybe switch to a new branch. Now sometimes it will throw you an error telling that, hey, you have some changes. Or let's say, for example, let's try this. So git check out main branch, and let me add this. So now the data is there in my staging area. Now let's try doing a checkout. So git checkout. Okay, it is still doing it. Sometimes though, you will see it will throw you an error telling that I cannot check out because you have some unsaved changes. Okay, now that's where we can make use of your stashed area. So what we can do is whatever the incomplete changes we have, we can move it to this area called stashed area, right? And then we can switch to the new branch. So basically this will be clean, right? And we can switch to the new branch without taking that incomplete work, right? So git stash is used when you want to record the current state of the current working directory and the index, but want to go back to a clean working directory. So basically I have some changes, however it is incomplete. Now for some reason, so here you see it is showing me this file. Now for some reason you want this to be clean, you don't want to show this. And that's where we can make use of the stashing. So git stash will take the dirty state of the working directory, that is the modified track files and staged changes, saves it on a stack of unfinished changes that you can get back at any point, any time. So what we can do is this incomplete work that we have, we can move it to the stashed area, and then we can get it back at any point we want. So the command saves your local modifications away and reverts the working directory to match the head commit. So essentially, that's what we can do. So if you want to save your data in the stash area, we can run this command git stash save. So here I can say git stash save. If you want to give a name, you can give it. If not, by default, your git stash will give a name to it. So I'll just run this command, and you can see saved working directory and index state on the main branch, and this is the name it has given. Now if I run the git status command, you see now my working tree is clean. So earlier I had my incomplete work. Now I have stashed it, meaning I have moved the data to this area called stashed area, and now my working tree is clean. Does this make sense?
Basically it will temporarily save the data, right?
Correct. So it is basically moving to a temporary location, and you can get it back at any point you want.
Okay, got it.
Any other questions, anyone?
No, Ravi.
Okay. Now, if you want to see what all data you have in the stash area, you can make use of this git stash list command. Okay, so this is the only stash I have. So this follows your array format. Okay, so git stash at position 0, and this is the stash we have saved. Now, if you add one more stash, this will go to the bottom, and at the top you'll have the latest stash. So as of now, I have only one stash. Now, if you want the stash back at any point you want it back, then you will be running this git stash apply command. Okay, so here I will simply run this git stash apply. What this will do is, now whatever I have in the stash area, I will get it back in my um, uh, working location basically. So now if I run this git status command, you see, I get the data back in my staging area. It will also maintain a copy in the stashed area. So essentially, I got this data back, but I also have a copy in the stashed area. So git stash list is to see the list, and then git stash pop. Now git stash apply and git stash pop both are used to get the data back from the stashed area. The difference is that your git stash apply, if you run this git stash apply, you get the data back, and also a copy will be maintained in the stashed area. All right, when you run this command. And if you run the git stash pop, this will also give the data, but it will delete it from the stashed area. So you can see this line dropped. So now my stash will be empty. I will not have anything. That's the difference you have. Then you have git stash show, which can be used to see the differences. So here, if I run this git stash show, so as of now I don't have any data in this stash. So let me save this. So git stash save. And if I look at this, so this will essentially show me the difference. So this is the file we have. There's one insertion. That information you can get it. Then you have git stash drop. Now at any point, if you no longer want any stashed data, okay, any data, if you no longer want it, you can go ahead and delete that by making use of this git stash drop command. So git stash drop, and it will delete it. So basically you won't get that data back. It will simply delete it from the stash area. And then we have your git stash clear. Now both your git stash drop and git stash clear are used to delete the stashed data. The difference is this will delete one at a time, and this will delete all the stash at the same time. So this is basically deleting one stash at a time. This is deleting multiple stash at a time. Questions?
No, Ravi.
Okay, so that's basically about your stashed area. Next, we are going to talk about merging branches. So in the last session also we discussed about it, right? So we saw what is merging and when do we merge your changes. So essentially, once you're done working on one branch, and once if your changes are ready, we can go ahead and merge those changes, right? So I showed you how you can do it on the local repo. I also showed you how you can do it on the central repo, right? So once the developer has finished writing the code or the feature on their respective branch, the code will have to be combined with the main or master branch. So merging is Git's way of putting the history back together again. So let's say you have your feature 001 branch. So you have the working area, you made some changes, you moved it to the staging area, and then you committed those changes. Now, you want to merge the changes. What are the changes you have done in the feature 001 branch? You want to merge it with your main or your master or any branch for that sake. That's where we go with your merging. So the git merge command lets you take the independent lines of development created by git branch and integrate them into a single branch. So to add the changes from one branch to another branch, you can merge the branches. So the command, the example that we saw in the last session, essentially, that is what you can do. So the merging can be done in two ways. You can use the git merge and you can use the git rebase. So we have two options. The git merge. So if you want to apply the change from one branch to another branch, we can use the git merge command. Should be used on remote branches since history does not change, and creates a new commit, which is a merger of the two branches. Now imagine you have a master or main branch and a feature 001 branch. Okay. So from this main branch, we created one feature branch. Now the developer has finished the work on the feature 001 branch and wants to merge these changes with the main or your master branch. So here we can make use of your git merge command, which will create a new commit, which will have the changes of feature 001 and the main branch combined. Okay, so here we can do a merge. So from this branch, we create a new branch, make the changes, and then we can merge it with the main branch. Now, after this merge, any new commits that you do in this feature 001 branch will be isolated from the main branch. So Unless you don't merge the changes, the changes are isolated. It will stay in that respective branch only. Make sense? Questions?
Yes, Ravi.
Now to merge your new branch changes, you need to check out to the main branch by running the git checkout main command. This will take you to the main branch. Once you're in the main branch, you can run the git merge branch name to merge the change from the new branch to the main branch. If you want to know in which branch you're in, you can run the git branch command. Okay, so you already seen the example for this. And then you have the git rebase option. So this is an alternative to your git merge command. So this should be used on local branches only, since history does not change and will be confusing for other team members. Does not create any new commit and results in a cleaner history. The history is based on common commit of the two branches. The destinations branch commit is pulled from its base and rebased onto the latest commit on the source branch. So imagine you have the branch, the main branch, and the feature 001 branch. Now the developer has finished um, working on your feature 001 branch, but let's say the main branch moved forward while the code was being developed. So basically example, let's say you and me, we are working. Now you are working on your own branch and I'm working on the main branch. Now what you did, from the main branch, you created a branch, a feature branch, and you started working on that. Now, while you were working, the main branch has been updated. So let's say I have pushed some new changes to the main branch, right? Now the code being developed is related to the new commit added in main branch. So essentially, therefore, you want all the changes from the main branch to feature 001 branch. So now whatever the new changes that I have updated in the main branch, you may want that in your feature branch as well. Okay. Now, since it is a local branch, you want a cleaner or linear history. So you can use this git rebase source branch command. So the difference between your git merge and git rebase is that your git merge will maintain a commit history telling that, hey, there was a merge that happened. Your git rebase will not maintain that history. Okay, it will not have any history about the merges that you will be doing. That's essentially the only difference you have. So this is how the commit looks like after a rebase. The commit was rebased from the first commit to the next commit. And looking at the history, we can clearly see it is a clean, linear history without any branches. Questions?
So basically, don't save any history commits, right? Like,
So basically, it will not generate a new commit telling that there was a merge that happened, but your git merge command will generate a new commit telling that there was a merge that happened.
So how will we in day-to-day life, like while how will it be beneficial? So does it make any
So
difference?
yeah, I mean, see, imagine if you're using git merge on your local repository, what happens is it creates a lot of confusion. Okay. Or let's say you're using a git rebase on a central repository, and if you don't have a history, how will people know whether the changes was merged or not? Like for example, let's say you have pushed some changes to the central repository. I will also push some changes to the central repository. Now, I want to merge the changes, your change and my change, right? If I run the git rebase command, it will not create a new commit telling that your change and my change has been merged. Now, how will we know, or how will others know when this change was merged? Because there is no commit history now. Right? So it creates a confusion. Whereas your git merge will maintain that history. So that's why it is recommended that you git rebase, you use it only on the local repository. Don't use it on the central repository.
Okay.
And your git merge, use it on the central repository. That's the recommendation we have. Any other questions?
No, Ravi.
Okay, cool. The next thing we are going to talk about is our pull request. So again, we saw an example for this. A pull request is nothing but it's a merge request that we do on the central repository. Okay, so at any point, if you want to create a pull request, you want to create a merge request on the central repository, we can make use of this for that. So pull request can be used to tell others about the changes you have pushed to a branch in the central repository. So this is always going to be on the central repository. Okay. So once a pull request is opened, you can discuss and review the potential changes with collaborators and add follow-up commits before your changes are merged into the base branch. So, so essentially the whole point of your pull request is to ask someone telling that, hey, I've made some changes. Can you please review this? And if they're okay with that, we go ahead and merge it into the destination branch. So create a pull request to propose and collaborate on changes to a repository. And these changes are proposed in a branch, which ensures that the main branch only contains finished and approved work. So that's the whole point of it. We are not going to mess with the main branch, okay? Because the main branch will always contain your production quality code, right? So what do we do then? Well, we create a separate branch and we start making the changes on that branch. And then once it is ready, we ask someone to review it. Okay. And once it has been reviewed, we go ahead and merge it. So, I mean, this is again from the command line. So to merge a new branch, check out to the main branch by running all this command. We've already discussed about it. Okay. Now, the next very important topic that we want to talk about is solving your merge conflicts. No one asked a question on this, but imagine you have your how do I put this? Two people. Okay, so you have two people who are working now. Let's say you and me. Now you and me, we are working on the same project. We are working on the same application. Now you have some task and I have some tasks. Now you are, let's say, working on the index.html file, and I am also working on the index.html file. Now you don't know what I am working on, and I don't know what you are working on. Now let's say you will go ahead and make the changes and you will push it to the central repository. Now when I try pushing the changes, I'll get a conflict. So for example, okay, so assume we'll create two folders here. So let's call this as so just imagine these are two different machines, okay, worker one and worker two, just for the sake of example, just imagine. Okay, now let's say both these workers, they will clone the central repository. So let's say um, so we'll clone this. So let's go to worker one and we will do a git clone. Now the same your worker two will also do, right? So now both my worker one and worker two, they have the repo. Let's say worker two will start working. So let's say in this file itself, and let's say this is a change from worker one. So we will add this, we will commit this. So let's say this will be worker two, or it's okay, worker one changes, and we will push this. So git push origin to the main branch. So I'll give the username, password. I don't know where I have it. I think I forgot where I kept it. It's not the one. Sure. Sorry, give me 1 minute. I need to find that. Finally. I'll have to generate a new one. I don't know what happened to that. Settings. Let's go to developer. Access tokens. Generate a new one. We'll need to set a name. You can give whatever you want. Then we'll set the permissions. It's loading in a moment. Audible to you, right? There's no problem with the audio.
No, I'm able to follow up.
So GitHub down. Sure. Everything is working properly. And sorry, give me a moment. It's not working.
In companies, like, how do they use Git and GitHub? So they'll have, like, they will log in from their, like, company's mail ID, right? Or like, will it be, like, Teams email ID or something like that?
No, so this is going to be an individual account, so at an organ, like at least in PlanView. So we sign up with our official email ID, like we sign up to GitHub with
Okay.
the official email ID, and then someone will add our email ID to the respective repositories, and the rest remains the same. Creating your tokens and everything, you will be doing it the same way, and you
Okay.
will be authentic. But yeah, you'll have an official account that you'll be creating with your email ID, the company's email ID.
Okay.
Okay, so this has been pushed. So now no problem until here. Okay, so you will see my developer has pushed the changes. So here you can see this one. Let's say the other worker will also start working now. Okay, so let's go here and go to the repo, and let's say the same file. Okay. Now here, if you see, we don't have the change which was done by the other worker, right? So we don't have this change. So let's go ahead and do this. This change was made by worker. Okay. Add this. I will commit this. This will be worker 2 changes. And now when I try pushing this, so git push origin main. So I'll give the username, I'll give the password, and you see it is rejecting. Okay, so rejected, failed to push some references. So this is essentially what your merge conflict is. So now your GitHub, it is basically complaining that, hey, I have something, I have some changes, I have some data which you do not have, and there's a mismatch, and I cannot accept your changes. This scenario, we call it as a merge conflict. Does this make sense?
Yes, Ravi.
Now, how do we solve this? Well, if you're on the local machine, you have a tool for that. And the same, if you get on the central repository, you can do it on the central repository as well. How do we solve this in the local repository? So merge conflicts occur when competing changes are made to the same line of a file, or when one person edits a file and another person deletes the same file. So to resolve a merge conflict caused by competing line changes, you must choose which changes to incorporate from the different branches in a new commit. So essentially, this is what you will have to run. So we tried to do a push, we are getting an error. Now we'll have to run these commands. So git pull -- rebase origin main. So now see here it is not telling me which file is causing the conflict, right? So for that I can use this git pull -- rebase origin main. Now this will tell me which file is causing the conflict. So you can see conflict content merge conflict in index.html file. Now once you have that, we have this tool called git merge tool. We can use this. So essentially now what you have to do is you have to merge the changes done by worker 1 and worker 2. You have to merge them together and then push it. That is essentially what we have to do. So when you run this command, just hit enter and this will open up 4 files. The middle one that you see, that the original file without any changes. This is the changes done by, I think this is a worker 1 and this is a worker 2 and this is the final file. And here you basically do a merge. So basically, now let's say my changes and Prokshit's changes is causing a conflict. So we both will have to sit together and decide on what we need, what we don't need, and we have to merge the changes. So essentially here, I will go ahead and remove whatever I don't need. Like in this case, so essentially we are doing a merge over here. So this is worker 1 changes. I'm just deleting the unnecessary lines, which I don't want. And this is how my final file will look like. Then we'll have to save and exit. Now this is a VI editor. So escape colon WQ, we'll have to do it 4 times. Escape colon WQ, escape colon WQ, escape colon WQ. Essentially what this will do is this will merge the changes. You can see change done by worker 1 and change done by worker 2. Now it has been merged. Then we run this git rebase -- continue, and you'll need to give a message as well. And then git push origin. So essentially what we are doing here, we are basically merging the changes, the conflicting changes that we had. We are merging that together to solve this merge conflict. Now this is on the local repository. The same you may have in the central repository as well. Okay. For example, let's say we'll go to this branch, feature 001 branch. Now here, if you see, I don't have the changes, right? Now, let me edit this. Now, whatever we do on the local repository, right? You can do it directly on the GitHub also. Like I can add new files, I can edit it, everything can be done. generally it is not recommended to do this way. Okay, just to avoid conflicts. But however, let's say just to save some time, let's say this will create a conflict in the central repo. I'll commit these changes. Let's say I'll create a pull request. Yes, I'll try to merge two branches, which is my feature 001 branch and the main branch. And I can see here, can't automatically merge. Don't worry, you can still create a pull request. So basically now this is telling me that there's a conflict and I cannot merge it automatically. However, it's okay. We'll look at that. So we'll create this pull request. Now, when I try merging this, it will not happen. So you can see here, this branch has conflicts and must be resolved. Now you can do it two ways, use the web editor or the command line. So essentially what we did here in the command line, the same thing we can do in the web editor as well. So go use the web editor, and again, it's the same thing. So you can see here, it will show you, which of the line is causing the conflict. So basically the two developers for whom the conflict is there, they'll have to sit together, decide on what is needed, what is not needed, and then finally commit this. So essentially we are just combining the changes from the developers whose changes is having a conflict. So here we'll mark as resolved and commit this merge. And now I can go ahead and merge this change. So now I have resolved the conflict and I can go ahead and merge this pull request. That's your merge conflicts. Questions?
No, Ravi.
Okay. Next thing is your Git hooks. Now, Git hooks are simply your scripts. Okay, so Git hooks are scripts that run automatically every time a particular event occurs in a Git repository. So now if you want to run any kind of a script for any kind of an event, we can make use of your Git hooks for that. For example, let's say you want to validate the commit message by basically whenever anyone is committing the changes, you want them to follow a proper commit naming convention. You can make use of a script for that, which will validate, and if it does not satisfy, then it will fail. It will it will keep on telling you that, hey, your commit message is not valid, this is what you have to follow, right? For that we can make use of your Git hooks. So these are simple scripts that you can write, and they help you to customize the Git's internal behavior and trigger customizable actions at key points in the development lifecycle. So all Git hooks are ordinary scripts that Git executes when certain events occur in the repository. This makes them very easy to install and configure. Hooks can reside in either local or server-side repositories, and they're only executed in response to actions in that repository. Now, on your local repository, all of your hooks, they reside in this .git folder. So if you go to this .git folder, you should be able to see this hooks folder. And inside these hooks, you should be able to find all the scripts. So these are some of the default scripts that gets created for us when we create our local repository. So Git hooks reside in the .git/hooks directory of every Git repository. Git automatically populates this directory with example scripts when you initialize. So these are all your example scripts. So you can see here commit message. So if you want to if you want your users to follow a proper naming convention for commits, so here you can see an example hook script to check the commit log message called by the git commit. So every time we run the git commit command, this script will get executed. So the hook should exit with a non-zero status after issuing an appropriate message if it wants to stop the commit. The hook is allowed. So essentially what this is doing is well, I'm not 100% sure. So This example catches duplicate signed off by lines. So it is doing something. So likewise, if you want to, like, want your users, your team, to follow naming convention, your git commit naming convention, you can make use of this for that. Likewise, you have a pre-commit. So let's look at this. An example whose script to verify what is about to be committed, so called by the git commit. So again, um, um, yeah, I mean, I'll have to look at the script essentially, but I hope you I hope you get the idea. So likewise, you have the pre-push, pre-rebase, pre-receive, push to checkout. These are all the sample scripts. Now, if you want to create your own scripts, you can do that. For which event you want the script to be executed, you can do that. Okay. Now, these represents, so this one, most of the available hooks, but the dot sample extension prevents them from executing by default. So if you see all of this script, it has this dot sample extension. Now, this dot sample extension is basically disabling these scripts. So to install a hook, all you have to do is remove the dot sample extension, or if you're writing a new script from scratch, you can simply add a new file matching one of the above file names minus the dot sample extension. So if you remove this dot sample extension, these scripts will be activated. And whenever any of that event occurs, these scripts will get executed. Questions?
No, Ravi, understood.
No, sir.
Okay. Then you have the Git GUI. Now, working with the command line is one way. So whatever we are doing over here, this is your CLI. Now, Git also have your GUIs that are available that you can use to do whatever we are doing here on the local repository. Everything can be done from a GUI as well using a GUI tool. So if you have installed Git on your Windows machine, by default there will be a Git GUI that would be installed. But you can find any a lot of options for your GUIs if you want to use the GUIs. So here you have GitHub Desktop, Source Tree, extensions, .os Git, Git Kraken, Magit, Tower. So all these are your UI based tools that you can use to work with your Git. It's up to you, whatever you are comfortable with. I would suggest you to stick with the command line, um, simply because command line gives you a better understanding of the commands, how your Git works. It's more of a point and thing, so you may not get the understanding of how your Git works. Give me 1 minute to add some more. GitOps. Yeah, so I also want to talk about collaboration in GitHub. Now, see, the whole point of your GitHub is collaboration, right? Like you want to work with other people. That's the whole point of your Git and GitHub. So you're going to talk about a bit about your collaborations, right? So um, collaboration in GitHub is very important aspect of software development, and this basically enables developers to parallelly work on the same project. Like, for example, I have this repo. As of now, only I am contributing to this repo. And let's say I want all of you also to start contributing to this. I will need to add you as the collaborators to this project. How do we do that? Well, you can go to the respective repo, go to settings, and here you can see collaborators. So as of now, I don't have any collaborators. So you can see 0 collaborators. So now I can start adding people. So meaning, I can invite you people, and you can also start contributing to this particular repository. Can you ping me your GitHub username or the email ID that you have associated with your GitHub?
Yeah, I've texted Ravi. Ravi.
Okay. So I have Prokshit. See, okay. I'll add that over here. Sorry. Okay, so that's your account. Add. Likewise, I'll add Sedu as well. Again, add people. And add. Now, essentially, what will happen here is both of you will receive an invite telling that, hey, so and so user is adding you as a collaborator for so and so project, and you have the option to accept that invite or reject that invite. Okay, so once you accept it, I will be able to see that over here. It will show me. So as of now, you can see here it says pending invite. Once you accept it, this will go away telling that saying that this person has accepted the invitation. Once you have accepted the invitation, so this is basically I am giving you the right access. You can start, you can clone this, and you can start pushing changes to this repository. That's basically your collaborators. Questions?
No, Ravi.
Okay. So collaborators are the people who will be working on your project. So anyone who is going to contribute to your project, anyone who is going to work on your project, we can call them as your collaborators. So collaborators, to add the collaborators to your repository, you can follow the steps in the GitHub repository. So whatever I have shown now, you can do that to add the people. So if you want to give access to other people, you can do this. You can give the access to them, and they can also start contributing to this project. Okay. And next is protecting your branches. Now, we discussed about your pull request, right? So let's go to this branch, and let's say I'll make some change to this file. So let's say test changes in the feature branch. I'll commit this, and this commit will changes. We'll create a pull request, so new pull request, and we will create this pull request. Now, once this pull request is created, anyone can go ahead and merge this pull request, right? So here in this case, you see, we are able to merge the changes, right? So my changes has been merged. Now, let's say you have multiple people, like all of us in the team, right? All of us are working in the project. Now, this is not the right way, right? We want to have some sort of a protection on our production branch. Let's say main branch, that's our production branch, right? So we want to have some kind of a protection on that, such that only when people, once it has been approved, only then you can merge it. So now if you see, we did not ask anyone to review it. We did not ask anyone to approve it. I was able to go ahead and merge it. Now imagine you missed out something. There was an error and you missed it. How we can avoid that? That's where we have your protecting the branches. So using this feature, you can restrict access on how commits are made to the branches you specify. Okay. So now let's say I want to protect my main branch. Okay. So I'll go to settings, and here you can see this branches. We'll go there, and we are going to add a branch protection rule. Okay. So what is the name of the branch? So it's going to be my main branch. You can have this rule for any branch you want. In my case, we are doing it for the main branch. And then here you can see require a pull request before merging and requires approvals. And how many approvals? So maximum you can have is 6, meaning only when you get 6 approvals, you'll be able to merge it. So we will go ahead with that. Okay. Now you can see require review from code owners, right? So requires an approved review in pull requests, including files with a designated code owner. Require approval of the most recent reviewable push. Require status 6. So all this, so require signed commits, require linear history. You can put all these things, right? So we'll go with this require approvals, and we'll create this. Now let's say I will make one more change. Let's say we'll go to the feature branch, we'll go to this file, and let's say again I will make one more change, not merge these changes. I'll commit this. Now again I will create one pull request. Okay, so new pull request, and again this is going to be between my feature branch and the main branch, and I'll create this pull request. Now you can see here reviewers, at least one approving review is required. So now this is telling me that hey, you need to add a reviewer for this. Now who are the reviewers? Reviewers are basically the collaborators. Anyone who has access to this repo can be a reviewer. So in my case, when I click on this, so Prokshit has accepted the invite, so I'm able to see his name. Sedu is not accepted, so that's why I don't see the name. So I'm telling Prokshit, hey Prokshit, can you please review this and approve it? So here I can say, please review and approve. So I'll click on this create pull request. Now a notification will be sent to Prokshit, telling that hey, a pull request has been created and all those things. Once Prokshit reviews it and approves it, so you can see here it says review required, and you can see with whom this is pending. So only when Prokshit will review this and approve this, I will be able to merge my changes. So this is basically your branch protection. So now you can make sure only the good code or only the reviewed code is getting merged. Make sense?
Robbie, all to stop here. Is that your finished speaking? Because I'm
Sorry,
not able to.
sorry.
Your screen is not sharing lights.
Is it?
Oh,
Arjun?
I'm able to see. I'm able to see.
Okay, it's my network. Sorry.
Yeah. Yeah. Okay. So any questions until here?
No, Ravi.
No, sir.
So, Prokshit, can you go ahead and approve that request? You should have received an email to your mailbox.
Did 1 second. Let me add. Yeah, I've added to the review.
Okay, so let's refresh this. It's still pending. There should be an approve option. You can share your screen and I will guide you with that.
Okay, sure. Start sharing. Are you able to see my screen?
Yeah. So there on the right hand side, yeah, get started. Right answer, yeah, get started. No, sorry. Click on that pull request, the one below one. Yeah, that one. That's
Yeah.
basically your pull request. Now here, if you scroll up, you can see there, add your review. Click on that. And on the right hand side, you see review changes. There's a drop down. Yep. Now approve. You see that second option which says approve. Yep. So that's basically how you approve the changes.
Okay.
So now the changes has been approved, and I can go ahead and merge the changes.
Okay, got it.
I'll share my screen now. So now you can see it's already done, and approval. I've got the approval, and now we merge the changes. So this is basically what protecting your branches is. So again, this is something very commonly followed at an organization level. You will see people protecting, especially the main branch and the develop branch, especially. Okay, you won't be able to push the changes directly to these branches. You will be able to push only when someone approves it. Okay, the reviewer, whoever you have added as the reviewer, once they approve it, only then you will be able to merge the changes. That's basically protecting your branches. Questions?
No, Ravi.
No, sir.
Okay. Last thing I have is a Git workflow. I will do this tomorrow. Git workflow and forking. We'll do this tomorrow. Okay. So tomorrow we will be able to finish this off, and if time permits, we will start off with your next tool, which will be your Docker. Okay.
Ravi, one question I had from previous session. So, like,
Yeah, yeah.
how do we, you said there are two types of tags, right? Lightweight and annotated. So, like, on the GitHub, how do we recognize under the tab section whether it is lightweight or the annotated? I mean, the one with the more details. So, does it come under the review version? I mean, that category. How do we recognize?
Yeah. So see, essentially, if we yeah, good question. Version 3.0. Correct. You know what? Let's quickly create one and see how that looks like. Good question. So let's create a new tag. And 5.0. Okay, I think that's what will show you. That's a message. Okay. So here, if you see, now this is a tag, and this has a message as well. And this one also has a message. Just trying to find a difference. Hold on. Tags. Should there. Version 2 there. Done. We created version 5. Version 5. Version 2. Let's release notes. Yeah, I'll have to find this. It won't. And I was hoping it would have this tagging message. So that's the tagging message I created. And okay, let me create one more.
So basically, like the lightweight, we cannot give the message, right? So that is the difference, is it?
Yes. So see the main difference you have between your, so this is a lightweighted tag. I'm not using the -a flag. If you're using the -a flag, it's a annotated tag. Okay. Now in this case, I'm not using the -a flag. That means it's a lightweighted tag. Now, the only difference you have between your lightweighted tag and your annotated tag is that your annotated tag will contain information as to who created the tag and also the tagging message. Okay, your lightweighted tags will not contain that. That's the only difference you have. So your annotated tags will have more information. Your lightweighted tags will not have that information. Does that make sense?
Yeah, got it.
So if you see this one, this is the commit message 5. That's a commit message. Whereas this one, if you see, this is the tag message that I had given.
Okay.
And this is a commit message that it is picking it. That's essentially the only difference you have. But both are still the same. Only difference is this one.
Got it.
Any other questions, anyone?
No, Rafi, thank you.
No, Robbie, it's clear.
Cool. Yeah. So that's it for today. We'll continue tomorrow. We'll finish off with your Git and GitHub tomorrow. And if time permits, we'll start off with a new tool, which will be a Docker. Okay. Thanks, guys. I'll see you tomorrow. Bye bye.
Bye.